Physics 2. This is RC circuits. Okay. So here we have our voltage supply. We're setting back up the way for the first step of the lab. Voltage supply we're going to set to about 5 volts. Power comes out of the voltage supply, runs through a current sensor that allows our Logger Pro to detect the current. This runs to the positive terminal on the board. The positive terminal then comes over here, jumps over to a 100K resistor. Okay, it's going to pass through that 100K resistor to this other jumper, which brings it to a 3-way switch. Okay, check with the manual to see exactly what the 3-way switch does. It has 3 different settings. The upper setting will charge the capacitor. The middle setting does nothing, it's neutral. And the lower setting discharges the capacitor. Okay. So we have the middle section here connected to the capacitor, so it can either charge or discharge. Our voltmeter, which again, through Logger Pro, is connected to this 10 microfarad capacitor. Okay. And then the negative on the capacitor comes around to ground. Also, the ground is also connected to the switch, which runs back to the ground to the power supply. Okay, so that's our setup of the board. For section 1 of the lab, it is simply just setting it up and examining the switch and the purpose of that. Section 2 of the lab says to charge up the first capacitor. First thing we need to do is discharge it to make sure that there's no current stored in it. So what I'm going to do is I'm going to take this and put it to the all the way on the bottom. That will discharge out the capacitor. The power supply is on, set to around 5 volts. And what we're going to do now is charge the capacitor. So what I've done here in Logger Pro is set it up for the RC circuit. Okay, I'm going to hit collect up at the top, and I'm going to switch our switch to the upper position, which will charge the capacitor. Okay, and if it does it correctly, we should see it as an exponential. So there's the screen. Let's hit collect, and flipping the switch now. Okay, you can see the voltage there is still climbing a little bit, but it's starting to kind of max out. It does take about 20 seconds. The reason why it's a long one is because we're going to do an inverse exponential fit. And that's what we have here. We're going to take and move our bars so that it's where we want them to be, so it only grabs this exponential. Now you'll see that that is a black line that's following that red line. That is a very good fit. And then it'll give us an A, a B, and a C, along with some error, some uncertainty in those values. These will be recorded in Excel for you. Okay. For section 2, it asks us to fit the data 4 times. So section 2.7 here, we'll be repeating this 3 more times so that you'll have your data in your Excel. And then you're going to go ahead and also compute the capacitance based on the data that you have and the time constant. Okay, and then we'll move on to section 3. Yeah, for the RC currents, RC circuits. Now we have hooked up our board to a different capacitor. But before we do that here for section 3, just to finish it out, we're going to analyze the data that we got from the first capacitor, from the 10 microfarad. We're going to go ahead and average the C component that we got from Logger Pro, which is not the capacitance. It does present a little confusion there, but C Logger Pro is not the capacitance. It's actually the inverse of the time constant, RC. It'll be labeled as such in your Excels. C, the capacitance, is what we were calculating. We can take that time constant and divide it by the resistance to just give us the capacitance. And the capacitance here is marked as a 10 microfarad, so we'll compare those two values with a 20% uncertainty of the marked capacitor. Okay. Moving on to section 4, we have now connected to a new capacitor. You'll see that it still goes through the 100K resistor, and then it's from the center point on the switch, it comes over to this blue capacitor that we now have. That is where our voltmeter is now connected, and then that of course runs to the negative side of the switch. So once again, we're just going to repeat the same experiment with this capacitor and determine its capacitance. Okay. So once again here, I want to go ahead and discharge the capacitor. Just put that all the way in the bottom position. That'll start to discharge the capacitor. I'll turn on our voltage. We have around 5 volts. Okay. I'll come on over here to Logger Pro. We'll hit collect, and I'll flip the switch. That's a very familiar looking graph, very similar to the one that we got before. It's going to have some different values to it, obviously, but it's good that we're getting the same shape. And there's our line fit for an inverse exponential. Okay, so these values here will be recorded in Excel. We'll do this 3 more times, so you'll have 4 values that you can average, find standard deviation of, and percent uncertainty for, to determine the capacitance of this new capacitor. Then we'll move on to section 5. Okay, for section 5, RC circuit, we're going to go ahead and take our 2 capacitors that we have, the 10 microfarad you see there in the yellow, and we're going to connect it in parallel with the blue capacitor, which in the last section we found to be 22 microfarad. Connecting the 2 capacitors in parallel like this, the capacitance should add together. So we will go ahead and use Logger Pro to measure this capacitor as it charges. So we'll start discharging, let those 2 discharge down, and then we will come on over here to Logger Pro, hit collect, we'll let them start to charge. Okay, gives us our new values for A, B, and C for our auto fit. We'll take that value for C, put it into the Excel, calculate the capacitance, and see if the capacitance that we're getting through the graph matches our expected capacitance of just the C1 plus C2 that we had found previously. Okay, so we're going to do that just the one time for this one, section 5. Moving on to section 6. Okay, here we are for section 6. As you can see now, from the mid switch here, the red cable comes in, passes through the first capacitor. This is where the voltmeter is attached. There's a jumper, this green one here, that comes around and hooks up to the second capacitor. That capacitor then comes around to our other lead for the voltmeter, and the green, of course, goes back to ground. So this would be the 2 capacitors in series. I've already discharged the capacitance. We're going to go ahead and start this collecting and flip the switch. We see a different graph. It climbs very rapidly in the beginning, which is hopefully what you would expect given the 2 capacitance in series, and how to find equivalent capacitance. So there's our values. We're going to go ahead and use value C here to calculate the capacitance that Logger Pro has found for us and see if it matches.